Hi, this is Mrs. Lemke, and I'm going to go through some questions from the quiz. These are the most frequently missed questions from the quiz. So this one is pretty involved. It's asking you to compare two scenarios. As you read through this, you need to recognize that you're reading about two different possibilities. There's an account that does 5% interest, and it's quarterly interest. So that one is going to make use of the formula that isn't for continuous. It's the one that's for like periodically compounded interest. And that's A equals P and then parentheses 1 plus R, the rate as a decimal over N, where N is how many times compounded per year. And then that same value N multiplied by how many years. So when I look at that statement, I need to read back a little bit to see that the initial amount was $4,000. And so 4,000 is my principal investment. One is just one. My rate here needs to be my rate, which is 5%, but I don't write it as 5 because it's a percent, which means 5 over 100 or 5/100ths, which is 0.05. So in place of R, I'm going to write 0.05. It says interest is compounded quarterly, which means 4 times a year. So this is also a 4 up here. And then it mentions down later in the question that this is a 6-year time frame. So I'm going to put a 6 right there. Now, I would suspect that if you have problems with this kind of question, it might have to do with calculator usage. And so we're going to look at how this actually happens in terms of order of operations. So if you had to figure this by hand, you would need to do what was inside the parentheses first, which is 0.05 divided by 4. And then add a 1 to it. So 1.0125. And then the exponent was 4 times 6, which is 24. And the exponent's going to happen after parentheses. And then my initial investment, let me double check that because I couldn't remember, is 4,000. So I'm going to multiply that result by 4,000. So 53.89 and 40 cents. Get that one more time, 40 cents. Sorry, the memory is the first thing to go in aging. I'm just putting that out there. All right, so that's what we get in that scenario. Okay, the next scenario was the other account number 2. Still going to be $4,000, still going to be 6 years, but it says here that account 2 has a different interest rate of 3.5%, and it mentions continuously compounding. Well, for continuous compounding, you use the amount equals principal times e to the rate times time, or the PERT formula. And as I mentioned, it's still the same principle. E is a number, just like in the previous formula, 1 was a number. That doesn't change in any case, right? It's part of the formula. And then 3.5% means 3.5 per 100. So I'm talking about 0.035 as being my rate as a decimal, and my time was 6. So in this problem, you might be able to just type this all in as 1, but bear in mind that you need to be careful that all of this is an exponent. Okay, so let's see if we can manage that. So 4,000 times, and now I need an E key, and that is right over here. And then my exponent, I'm going to put parentheses there just as a security measure, just to make sure that the calculator understands I want all of this in the exponent. Did I get those values right? I should probably have a copy of this in front of me, but I'm just flicking back and forth instead because, live dangerously. So 49.34.71. Okay, and that's less. We would generally, like if the interest rates were the same, we would expect that we would get more money with the continuously compounding, but that interest rate was less, right? It was 5% versus 3.5%, and that made a significant difference. So in our answer, we want to say that we would have more money with account 1, and then it asked us to find the difference between those. 40. Okay, so I'm gonna see how far apart they were. So about $454, which is this one. Okay, so hopefully I did that right. I hope that that's right. A little nervous because like I said, I didn't have my paper in front of me. Bad planning. All right, over here, it says state if this equation represents exponential growth, decay, or neither. And you might remember from the review sheet and from Mr. Lakin's video that exponential growth or decay has to fit this kind of form where you have like some number with an X up here, right? It has to be like that. This A could be anything, including a 1, so you might just not have anything there if A were 1. But that's really the critical thing, is that you have a numerical base, like a constant, like 3 or 7 or something, and then the exponent has an X in it. So that means that this is neither one. In fact, we had a unit studying this kind of equation. This kind of equation is the one that has X squared in it, and we call that a quadratic. The graph of that will be a parabola, not an exponential growth or decay. All right, this one, you need to just remember that logs are exponents. So this question is saying 2 to the what equals 32. And if you check your number sense, 2 to the 5th is 32, so you should have dragged the 5 into here. And this next one is saying 27 to the what equals 3. So I want to think, well, I need to have it get smaller. And so I must be taking a root. And I know that the cube root of 27 is 3. So this exponent must be a third. So that's what you should have dragged in. This is saying 1/5 to the blank equals 125. And I know that 5 to the third is 125. But here I have 1/5, so I need that to flip over, right? The 1/5, I want it to be 5 over 1 instead. And so this box should be a -3 right in there. And the last one is saying 10 to the blank equals 1,000. And that is also 3. All right, I hope that this helped. Thanks.